Okay, so in this example here, I'm going to calculate the lattice enthalpy of formation of sodium sulfide. So sodium is in group 1, so it will form a plus ion, and sulfur is in group 6. It will form a 2 minus ion. So the formula for sodium sulfide has to be Na2S. Okay, so if I write down the balanced symbol equation, then I am going to need 2 sodiums, 1 sulfur to give me sodium sulfide, which is a solid. Okay, so I can write my enthalpy equation from that. So if I start, actually I'm going to start a little lower down to give myself space. So if I start here, so if I've got sodium solid and sulfur solid, I need 2 lots of sodium. Right, so I'm going to just do the transformations on one of these. I'm going to do the transformations on the sodium. So the sodium I'm going to turn from a solid to a gas. I'm going to atomize it. Then I'm going to ionize it. So I've got 2 sodiums. I'm going to ionize the sodium to give me the positive ion, and I've got 2 electrons. And then I'm going to put my sulfurs back in. Okay, so I've got sodium as a gaseous ion. It's in its final state. I now need to do the transformations on sulfur. So sulfur is a solid. I'm going to turn it to a gas. So sulfur gas. And here I've got my 2 sodium ions and my 2 electrons. Then what I'm going to do with this, I'm going to ionize it. So I'm going to add an electron into the sulfur, and that's always an endothermic reaction. So I've got 2 sodium, that's a gas, 2 not 2 electrons, only 1 electron, because 1 electron's gone into the sulfur. So I've got sulfur. Okay, then the next thing that's going to happen is this is going to take in the second electron, so the second electron affinity, and that's always positive. Okay, I'm running out of space here, but I'm going to just put it on this anyway. So 2 sodiums plus S2 minus as a gas. And then the final thing that happens is these are going to form my sodium sulfide solid. Okay, right, let me put some values onto this. So this is where I can use these values here. This was question 2. The lattice enthalpy of formation for sodium sulfide, I have to calculate, so I have to calculate this. I will have been given this, and the lattice enthalpy of formation is minus 370. Okay, now I need to make sure I take account of these 2's all the way up here. Okay, atomization of sodium is 107 plus 107, but I had 2 of them. Ionization, first ionization enthalpy is plus 496, but I have 2 of them. Okay, sulfur, that's all. I'm not going to ionize them any further. It might have given me these, but I'm not taking it any further. So this is sulfur here, so I'm going to atomize sulfur. Here's sulfur, so the enthalpy of atomization is plus 279. First electron affinity is here, minus 200. Second electron affinity, plus 649. That's not a very good wave. I'm going to do that again. Plus 649, and then this I have to find I have to find out. Okay, so I know that going from here down to here is equal to going from here all the way round and down to here. So I'm going to set up my equation that minus 370 equals, and then I'm going up here, so 2 times 107 plus 2 times 496 plus 277. I'm still going with the arrow, minus 200 going up plus 649 plus the lattice enthalpy of formation. So I'm going to simplify these numbers and then rearrange. Okay, so I realised I've made a mistake here. This was 279 from the table, so I've just made that correction there. I've calculated these out, so this is 214, this is 992, 279, and these stay the same. So when I've simplified this, I've got 1934 plus the lattice enthalpy of formation. So if I rearrange this now, it's minus 370, take away 1934 equals the lattice enthalpy of formation. So if I work that out, 70, that means this side is minus 2304 is the lattice enthalpy of formation. So as we create our solid lattice, it is exothermic, and I'm just going to check. It asked me for the formation and not the dissociation. So question number 2, calculate the lattice enthalpy of formation. Okay, if it had asked for lattice enthalpy of dissociation, then this would have been the exact opposite, so it would have been 2304 is the lattice enthalpy of dissociation. So I would have taken the lattice and I would have created the ions, the gaseous ions from that. So I hope that helps you with that one.